Hey guys, my name's Donnie, and I've been working on this project here for a little while, and people have been asking me a couple of times to make some videos on it, to talk about it, and stuff like that, and I've never really felt like I'm in a good position to kind of do it, but recently I've been making some pretty good progress with it. I thought that would be a good time to maybe talk about it and get some feedback. So any feedback would be very much appreciated. Anything at all that you think could be improved, whether you think it's a good or a bad idea. To talk a little bit about the project, the name of the project I've given is AIPI, which stands for Artificial Intelligence Programming Interface. Essentially, it is a framework for Unity, where I'm able to create games where the player essentially uses programming to play out the game. So rather than your traditional kind of game where you're using the keyboard or the controller or your mouse to control your objects, in this particular type of scenario, I'm making games where the player is going to create programs for their objects. But what I will say is that I'm not currently making a game just yet. I'm still working on the framework, so what you're going to see here is not really going to resemble a game. It's more just to kind of show off the core premise of what I'm making and get some feedback on it. So without further ado, let's have a quick look at what the programming is going to look like. I think that's the main thing that people probably want to see. So if I just kind of open this little thing up here, this is essentially what the programming looks like. So as you'll probably see already, it is a drag and drop programming interface. It uses a node style programming. So for example, I can kind of pull in some nodes here and draw the flow of the program like that. So sorry, I should have said that this particular node here is the starting point of every program. So when this program runs, it's going to start here and then it's going to flow out here, flow into this node, and then depending on whether this condition is true or false, it's either going to go up here or go down here. So this is a real kind of basic example of what the programming looks like and how you might use it. So a really simple example of something that we can kind of do here to show off a little bit of the flair of this, or how nice it is to use. I've set up a really simple scenario where we have a single object represented here by a sphere. Blue is just to say that it belongs to me, as you'll see later on in this video. And in the top left here, we've got this section that shows some information about whatever object I have selected, and also the bottom right here shows the program that this object is running. Okay, so let's start with some really basic stuff. So this object that I've added to my framework is an object of type bot, and I've given this object two functions, one for the ability to set the object's name, and the other for the ability for the object to be able to move. So obviously not very exciting, but I think they'll hopefully show a little bit about this, enough to get hopefully some feedback anyways. So what I'm going to do is start by creating a new program. So I'll just go up here and we'll start by setting the object's name as just an example of some things that you can do. And it's worth quickly talking about this section here where I'm selecting the object type for this program. Because this is maybe a little bit confusing, I'm not sure, but essentially the framework it has a flair of programs. So a lot of these types of drag and drop programming interfaces, they kind of resemble a very loosely written programming environment, maybe something closer to Python or JavaScript, and you don't tend to really see any kind of I mean, this is maybe a personal taste thing, but for me, strict programming languages I feel are more resembling of the kind of the larger area of real world programming. So this kind of follows the stricter kind of mentality of programming a little bit. But also, in addition to that, we do have some object-oriented programming terminologies and functionalities within AIPI. Partly as an educational thing, but also because you're always writing a program for an object. So this allowed me to implement ways of kind of having some object inheritance, so you can write a program for like a root object, and then any of those child objects can also use it, so you get kind of thinking about that a little bit. And also, like, it works in a way where, like, this object has those two functions that I spoke about. Any child objects of that object would also inherit those two, so you've got the object inheritance side of object-oriented programming, which I think is a nice thing for people to learn, to kind of get around the basics of object-oriented programming. But I might be completely wrong about that, and maybe it's a terrible idea. Please do let me know. But it's kind of hard to see here, but the bot object type does inherit the world object. So if I made a world object program, any object basically would be able to use it. But in this case, I'm going to make one for bot because I want to expose those functions I'm looking for. So this program will set the name of a bot. Okay, and you can kind of see it here now. I'm in this actions section, which is showing me the two actions that this object can commit, and you can kind of see the difference. If I go to this program where it's designed for world object type, there is no actions at that part in that point in the hierarchy, but there is at this point in the hierarchy. So obviously really simple. I would simply just drag this in and everything is going to work. But I'll quickly talk a little bit about one very useful thing, which is you might have noticed it when I'm hovering over things. It does give me a description of little things of what's going on here. But in addition to that, you do get some pretty useful information on these kind of bits here. So the outputs of these nodes, it explains why you would end up going out of this output. Also the parameter sections here, or the these kind of block sections where you would put another operator inside. It also describes here what expected value it has, and this is a really important thing, kind of what I was talking about earlier, where the framework is designed around strict typing. So for example, if I wanted to try and let's say put a vector in there, it's not going to allow me to do it. This goes red, it says it can't do it. But if I were to try and put a boolean in there, it would work, or it would let me. Anyways. Yeah, so setting a name then. So if we read this, it says here this is going to set the name. And if I read over this, there's not much of a description, sorry, but we know that it does expect a string. And for any simple types like this, this box turns into an input field, so I can just simply type a name like that. And we're pretty much ready to go. So if I just go and sorry, WASD controls the camera here, so it does kind of go off a little bit sometimes. I'm just setting the program on this object to the program I just made. If I just refresh that, so we can see it changing here. If I play this, it's not going to do anything. The name of the object still stays the same. I just need to join this up, and now we can see that the name changes. And the cool thing about this too is I can make any changes I want to the program in real time. I could even do something like this, and you can see it changing in the top left there. Everything happening in real time, which is really nice too, for testing and iterating your program. So the next good thing I think to talk about is the variables and how deep you can get within this programming. It's very, I think the depth of the level of depth that you can get from this programming is quite a bit more than I've seen in this type of thing. And the variables, I think, are a really good example of that. So a kind of I guess just a really simple example would be to have some string variables. So name one. So sorry, I'm going a bit quick there. I'm clicking this button up here to add a variable to this program. Essentially, this creates a local variable for this program. So I don't think I need to explain that. I think that's pretty self-explanatory. Name one. I'll just give it a rubbish description. Name two. And I'm also just going to add a use name to boolean. Name to. Alright. And we're just setting up a really simple example here of variables and how it all works, so you can kind of see that. So I've typed in var in this search field. You can also find it in this data category. There's a lot of stuff related to variables and so on. But this one here, it says access a program variable. And as we can see here, I've got the 3 variables that I made. And nice, you also tells you what type of variable is, the description and so on. And also if I select any of these, it changes the return type of this operator. You can see here it's now returning a string, and I change to this, it's now returning a boolean, so on, which is cool. So what we'll do is we'll set up a really simple control. Right, and as you can see here, it's still saying red because this returns string right now. Sorry, it's not allowing me to put it in here because it's returning a string. So if I change this to a boolean, it will now allow me to put it in there. And what we will do is use the variable again, and we're going to set the, oops, I didn't want those, I wanted. And interestingly, this program is actually running while I'm doing all of this. So it's a really safe system too, which is cool. Took quite a while to figure out a good way to do that. So that so that you could basically do all of this stuff in real time while you're sort of seeing it in action and so on. So essentially, this should be kind of self-explanatory, I hope. I would be quite confused if you're not quite understanding that part, but if you're not, it would be great to know why, if there's something I can do here to make this clearer. But the program is essentially saying it starts from this point, and we're checking if the boolean value is true or false for this variable here, which we know is a boolean variable. If it's true, it's going to go up here and set the name of the object to name1, which is another variable of type string. Otherwise, it's going to set the name to the variable name2. Now we haven't actually set the values for these yet. We could do that here. So you have a so again, you need your variable. So we could set the name to, you know, Bob, for example, if we wanted to do it that way. But I'm just going to do it in that interface, just to show it there, because it's easier, or it's nicer to show in this example, I think. So we can see here in the top left now, where's my object gone? There it is. So we can see in the top left here, we've got the variables that I created, and I can add some stuff into here. So we'll just say Bob for name1, Peter for name2, and let's just get rid of that. And the program's running, so if I just go true or false, so we're using variables here, so nothing is hard-coded within our program. And as you can see, everything is working as expected, and as you'd expect too, I can change it up here, you know, and you can see everything works as it should. So you can see already level of depth that you can get from this is already pretty cool. You can store objects within variables too, and lists too is something that I've added recently. Support for arrays. So you can go to an extremely deep level of complexity within these programs, and it's all relatively simple, I think, to set up and use. I think another pretty good example is to look at the move function of this object, and I tried to think of a good scenario or a good example of moving, and the best thing I could come up with was this. I was just going to set up a script or a program that would allow me to basically move between these two objects. So what we've got in this scenario here is again an object in the middle, which is an object that belongs to me, and then we've got these two objects on the outside which are red because they don't belong to me, which is a lot of way that the framework works to try and distinguish between my and not my objects. So yeah, I'll write a simple program that allows us to go basically back and forth between these two objects. I think that's a fairly good example of using variables and a combination of everything that we're talking about anyways. Okay, so I'll create a new program. So I'll call it ping pong because that's kind of what we're doing in a way. Not quite, but close enough. Move the bot between two enemies. Alright, now you might be thinking this is a really simple thing to do, but there's a little bit of complexity in this, in that when we move to this object, we want to be able to then move to this one, and then vice versa. So when we get to here, we want to then be moving to this one, and then be moving to this one. So we need to keep track of the object that we're moving to, and then when we get close enough to it, or when we arrive at it, we want to then switch to the other object. And there's a little bit of complexity in there, I think, anyways. Or it's complex enough for it to be interesting to show, I think. Okay, so I guess I'll start with I think the way most people would maybe approach this. So we've got this, we know we're going to use this. And one thing I didn't really mention is that this, if you hover over the parameter field for this particular action, it does accept two types. So you can specify an object, a world object that you move towards, or you can actually specify a vector. So you can actually input here I can just show you that as a really quick example. You can actually input a vector here, and for anyone that doesn't know, a vector is simply a coordinate or a direction, simply a value with or an object with x and y values. So if I play the program, you'll see it moving. You can see positions changing to 1, 1. I'm just going to put that back to 0, 0 for now. Alright, so yes, you can have certain situations where there can be multiple types accepted, which is quite cool. Okay, so I think how most people would approach this is they would see this find category and they're like, okay, I'm going to find an enemy object. So let's start there. So enemy bot. So sorry, I'm going a bit quick again. So this operator, as you can see, it's going to return an object of type bot. In this case, because I've selected bot, if I change this, it will return a different object type. So this is used to find an object. The first parameter here expects a enum of type relation. So essentially, we're just saying we're wanting to find an object of a certain relation type. In this case, we're looking for an enemy, and we can specify the object type, and in this case we're looking for a bot. So if I just fire that in, actually it'll be doing it already. It's just going to move to that object, but that's only part of the battle. So now we're stuck. How do we get it to find this object? Well, obviously we could do one thing, which is you'll see here this particular one. So if I look at the description, find the first object after sorting potential objects. So if I go find enemy bot again, and you've got this section here for distance operators, and we've got distance to target. Now target is a term I am going to be removing. It's, I think, very confusing, but in this particular situation, target is just referring to an object that is being filtered by, in this particular case. Very confusing, I know, I don't like it, it will be removed. Descending and ascending, so I probably should rename this to A to Z or Z to A, probably be easier to understand, or 1 to 0, 0 to 9, 9 to 0 maybe. But we're going to go from the furthest distance. So if we're doing this, then this is going to find the object, the enemy which is furthest away, and that's kind of a little bit closer to what we're looking to do, because right now we're here and the other object is over here, which is definitely the furthest away object. But as soon as we get to this middle point, in fact, if I even just do that just for the sake of it, as soon as we get to this middle point, the object's going to be stuck, because the two objects are both furthest away. They're both the same distance, so neither of them is the better choice in this situation. You can see it kind of shaking a little bit because it's constantly switching between the two. So this is where we need to kind of get a little bit clever here, because we need to keep track of the object we're moving towards and only change to the other object when we're happy to, when we've reached the object, essentially. So we're probably going to use this, but just not at that point. One thing that's really important to note too is that it isn't visualized yet, but each of these has a cost, and funnily enough I've called the cost CPU. I think that's the most logical, makes sense. But essentially each of these operators has a cost, and these find operators are the most expensive operators to use. So what I'm about to do with variables, essentially storing the value of this in a variable, is something you would be encouraged to do, because each program will have a maximum amount of CPU that it can use. So if you're filling your program with loads and loads of these, instead of maybe referencing an object that you've cached within a variable, then your CPU is going to max out and you're not going to be able to run the program. So let's just kind of start with that. So first of all, we're missing variables, so we need to create a variable to store the object that we're moving towards. So we'll say target object, and we're going to say that this object, and the object type in this case is a bot. We'll give it a description, the object that we're moving towards. Okay, and I don't think we need anything else here just now anyways. Let's just get rid of this, we don't need that. So what we're going to do is, first of all, let's check whether we have so we've got that variable started that I just created, so target object, and we can see here it's going to return target object type. Now the interesting thing to note about this, if you're not really clued up too much on programming, is variables of this type, so variables of objects are referenced types, which is something I'm not going to explain in too much detail. It can be null, which essentially means that they can have no value, and in this situation right now, it's going to have no value because we haven't set the value yet. So we can kind of have ourselves a situation where we can check whether the value is set or not, and we can do that with is set. So this allows us to check whether the value of this variable is set or not, and then if it's not, well, we can set it, or we can go on our merry way and move towards it or something like that. So I'm just going to continue to use this search field. I find it, for me, is easier than going through these, if you know what you're looking for. Okay, so sorry, variable again. Okay, so this should be self-explanatory, I hope, but if not, the idea is that we're going, if not in this case, so we're checking for the negative of a condition. So if not is set, the variable of target object, so essentially this is saying if the variable does not have a value yet, then go this way to set the variable target object to the furthest away enemy bot. Alright, I think that should make sense for most people. And if it is already set, then we're okay to move towards it. So we can bring that move to back in. And here's the interesting thing that I spoke about earlier. So let's just quickly stop this from running for a sec. So don't want it to run just yet. So earlier I was saying about the cost of operators and how they could max out your program and essentially cause it not to run. So because we've stored the value of that in a variable, we can now reference it with that variable. So I can use that here, and you know, this would be as opposed to having another one of these and then obviously your program being much more expensive, right? So this is I think a really nice little thing that AIPI does, is it teaches you also how to optimize programs by encouraging you to find cheaper ways to do things. And the CPU is expensive for this because it is actually expensive to do that in the back end, and how it actually has to iterate through all of the objects in the world, and then it's going to use some link to try and query against the objects and then sort them and so on. So this is actually expensive. That's why it's going to be expensive for players to use. So it's kind of real world optimization too, which is I think a really nice thing for players to learn. Okay, so far this should kind of make some sense, I think. So if the value is not set, then we set it. Otherwise, we're ready to move. And obviously, once we set it, we just go straight to moving to, because we can. We have a value to move to. So we can run that, and we can see that. Actually, we can see already that the target object has been selected, and this is something I'm going to change. It's I need to make a prettier way to display object IDs. It's currently just displaying a whole GUID, which is not great, a whole GUID. But you can see here that we have actually got a value set, so if I play this, it's going to move towards whatever object it picked up, which is the bottom one. And we get there and we're still stuck, but that's okay, because we simply now just need to find when we get there, so find a point when we're ready to switch to the other object. And I'll not go into too much detail on that just yet. I'll show you. It's easier for me to show. So the logic that we're looking for here is when the object, I guess, gets close to the target object, then we'll switch to the other one. So we just need another if here, and we have this distance section again for calculating some distance. So distance to object, we'll use this one, and we'll need our variable again. So distance to target object, so this is going to give us the distance to this object within our variable, and we're going to want to know whether it's less than a certain value. So you've got here this in this logic section, you've got this operator here, which means less than. It explains here, returns true if left is less than right, and it returns a boolean. So we know we can put it here. So we're looking for the value of the distance to be, let's just say 1. This is just world units in Unity, so that doesn't mean anything other than that. So if the distance is less than 1, then the easiest thing we can do here is the start of this program checks for the variable value being unset, and if it's not set, then it'll go through this process and so on. So all we really need to do here is just unset the value. So remove the value of this variable so that it will go back up into here and it'll find that object again. We could obviously at this point do another find at this point and then obviously not have to unset and basically never end up back in here again. But I think it's good to kind of think about stuff like that. I mean, I may be getting a little bit too ahead of myself with this, but that's how I would do it. So we've got unset here, so we'll just drag this in and read our variable again. Before I do that, I'm just going to pause this. Variable. Okay. Unset. Alright, so now that should work exactly as you expect. So what we're saying here is once the distance to the target object gets less than 1, we unset the value. So what will happen is that it will see that it is not set here when it runs that frame of the program, and it will go back up to here to set it and then go through the whole thing again. Alright, so if we just run this. Alright, so I don't know if we'll see it happening because it's super quick. It's like one frame it's going to take, and maybe we'll see it flash. Don't know if you saw that. Might see it setting here. Maybe a little bit. It's kind of hard to see. But there we go. That's it working, and it's doing exactly what you expect it to do. Pretty easy to set up. Pretty fun, I think, too. There's also other ways that you can do this. There's this tagging system as well, which is essentially here for a simpler version of variables. It's tagging is a way, or you can tag objects in order to help you find them again later, or to basically kind of broadcast to other objects that you have found an object of interest. A good example of tagging might be you want all objects to attack a single target, so you tag an object and then all other objects can find that object really easily. Obviously you could do that with variables too, but I find that tagging is something that people seem to understand easier, so that's why it's here as a simpler version of variables. So we could create a tag here for object instead of the variable, and we can basically do everything. So you have this find with tag that you could use instead of the variables, so you could literally just switch out all of that. Well, actually you would tag something here instead of setting a variable. Oops. So, where are we? Tag. I think my PC is doing an update, so I'm sorry if it's a little bit laggy. So yeah, so instead we would be tagging. Oops, no, not this. It would be tag object. Alright, we would do that. Okay, we need to do if not exists enemy bot with derp, then tag, then move to. So this obviously wouldn't be as cheap in terms of CPU as the other one, because we are using find here again. Obviously you could still use a variable, I guess, if you wanted to, but I think that's a little bit overkill in this particular situation. And then here we would need to untag. Tag object and target object. So So essentially this is going to do the exact same thing, but with tags instead, which means, you know, because variables obviously have to understand how typing works, or strict typing, and I think tags are a little bit easier to understand for some people. Sorry, I didn't stop the program. I assume it's still working. Yeah, so we'll see it. Still working. As you can see, there we go. So yeah, I would love to get some feedback on this. As I said, it's very much a work in progress, so there's a lot of things I do definitely hope to change within the framework itself before I start actually working on some simple games for it. But I'd very much love to hear what you guys think, what sort of stuff I could change, maybe if there's anything I could do to make it easier to understand or easier to use, or if I'm going in the wrong direction with something. Definitely open to any kind of feedback that you guys might have. And yeah, thanks very much for watching. Have a good day.